challenges with ammonia measurement depends a little bit on what source we're looking at. If we're measuring inside a cattle barn, for example, we have the challenge that it is a relatively complex source. So we need a specific measurement technique. The concentrations are not very low there, but we need to be able to measure in several different positions. It's not just one place that we can measure. A cattle barn is what we call naturally ventilated. So it means air blows in from the side or from both sides and can be blow out through the ceiling or through the other side of the building. So it's not a well-defined emission source in that sense. It's not just a pipe coming out with emissions where we can measure. So we need to measure in several positions, and we need to measure both inside the barn, but we also need to measure outside to correct for any background introduction of ammonia. And in order to obtain a reasonable time resolution in our data, we need to measure in a cyclical manner. We have one instrument typically, so we have to measure one position at a time. And if we have, let's say, 6 or 7 positions, and we would like to have a data point with a reasonable time resolution, then we need a measurement technique that can do this relatively fast, preferably within 5-10 minutes. We can shift position and get a stable signal. This kind of measurements require quite long sampling tubes. And so we need an instrument that can can really measure with this high time resolution. And of course, we also need a whole sampling system that can accommodate this. And so we use inert sampling tubes of Teflon, but also we need to have as high sampling flow as possible, and we need to heat the sampling lines and insulate them. Because ammonia is actually a really tricky compound because it's very sticky. It really sticks to sampling material surfaces if you're not careful, especially if there's a risk of condensation. It can really remove ammonia in the sampling system. So this heating and high flow, and also having an instrument where ammonia is not just adsorbed to the inlet of the instrument is extremely important. We can see that the cavity ring down systems that we have used can really provide this. If we go from the barn to the outside, we can measure, for example, emissions from fields, either by using so-called wind tunnels, where we place a sort of tunnel and have a controlled flow of air across the surface. And here we would like to have many of those wind tunnels placed on a field to measure different positions, but also perhaps different treatments of the manure that is applied, which is the source of the ammonia. And again, here we would like to have a high time resolution. So we typically measure, for example, 12 different positions on a field, and we need to be able to shift between the positions relatively fast and have a fast response time of the instrument and the sampling system again. And also, if we are measuring, an alternative technique to the wind tunnel is to measure downwind from the source and do some complicated modeling to actually calculate the actual emission. And there we need to also be able to measure fast because the emissions are fluctuating over time. And those outside measurements, we see quite low concentrations. So there we really also need the high sensitivity, which is provided by the very long optical path length of the cavity ring down system. That really is extremely beneficial. Open path optical systems is also a possibility to use in some cases. The reason why we have not gone in that direction is because we are a little bit concerned with the sensitivity when we have low concentrations, and we also know that it takes quite some time to adjust the optical path and make sure it's stable. So what we can see is that there's some scatter in the measurements with these systems, at least when the concentrations are low. Open path definitely has some advantages in that there's no sampling system. So the sticky nature of ammonia is kind of doesn't play a role there. But we prioritize I would say, high sensitivity and the robustness of the system we have chosen to use. But I would say definitely open path system is also a possibility. When we do calibration, we do that in the lab normally and with a dynamic dilution system. So we purchase a certified cylinder of ammonia, for example, 10 ppm, and we then do dynamic dilutions using mass flow controllers that are calibrated, of course, to achieve different concentrations of ammonia. One challenge here is that when we are calibrating at low concentrations, again, the stickiness of ammonia means that it can take quite some time to achieve stable concentrations. Heating and high flow in the sampling systems can, of course, help us there. It just takes time. Sometimes we also calibrate the system with sampling lines and everything in the field, bringing a gas cylinder to the field and then providing a known concentration to the inlet. Sometimes we are measuring through 20-meter sampling lines and sampling valve systems, selecting different channels and so on. So it's important to make sure that it's not just the instrument that is accurate, but the whole sampling system too. So we introduce known concentrations of ammonia, and then we make sure that the final measurement is accurate. So that's field calibrations that we do also from time to time. Also to check the response times in the field is important to make sure that we are measuring for sufficiently long periods on each sampling location. We would typically measure somewhere between 5 and 10 minutes, depending on a little bit on how many sampling lines we have and how long the sampling lines are. Then we have also investigated not just calibrating ammonia, but also looked at potential interferences. So we have introduced a variety of different compounds, including volatile organic compounds, but also methane and CO2 and humidity, to see if that affects the ammonia response. And what we can see is that, as we hoped, the influence is negligible. That's very fortunate. I think it is thanks to the optical system and the laser-based detection system that we can see that there are no interferences.